In this lesson, we are going to talk about how to solve a system of linear equations by graphing. And I believe that we already know how to find the slope and how to find the y-intercept. And when we graph, we always start from y-intercept, and then we are interpreting the slope by using the definition of slope, which is m, which is a rise over run, right? Rise over run. So how many you jump up and then how many you move to the right or left. So you can plot the next point and then you can draw the line. Okay, so two or more linear equations. When you have like two or more equations, it form a system of linear equations. It's called a system of linear equations. And many times we just call them system of equations. And we are going to find solutions of a system of linear equations. So solution means any order pair. It could be any order pairs that makes all of the equations in the system true, which means the order pair should make this red line true when it's plugged in, and this solution should this blue line true. So when I plug in, for example, if I plug in 2, let's say this point is 2, 2, 2 and 2, I'm going to plug in 2, 2 into this equation. Then it will be true because this point is on the red line. However, if I plug into the blue line, 2, 2, now I'm going to plug into 2, 2 into blue line. It's going to be 2 is equal to 2 minus 2. It is not true. So 2 and 2, it's not going to be the solution for the system, but 2, 2 is a solution for the red line. So you have to find a point which makes both equation true. Please copy it down. I'll show you the example. So number one, we have two equations in the system. So now this is a system. All right, so these two elements, we need to find a solution, x and y, which makes this both equation true. Equation true means like when you plug in this order pair, then both equations should be true, right? The equal sign should work. Okay, so now y is equal to x plus 2. So now we're going to graph it. So you have to, when you graph it, you have to find the y-intercept, right? Because we always start from the y-intercept, and we have to find the slope. So now y-intercept is what? The number itself, 2. And what is a slope here? What is a number multiplied to x? There's nothing. It means there's times by 1. So the slope is 1. And I already explained about this. When you have like whole number or integer slope, you better have like 1 over 1 so that you know that, oh, I need to move up, like 1 up and then 1 to the right because those two numbers are positive, right? So now let's graph this. So y-intercept is 2. So 2 should be here. 2 should be on the y-axis. And from here, this is the starting point. You're going up by 1, going up by 1, and going to the right by 1. So the next point is going to be here. You only need 2 points to make a straight line, but if you want to go up to double check, then you may go plot one more point. Go up by 1, going to the right. Go up by 1, going to the right. So if I connect all the points, then I'm not going to connect until I get the next one, but if you plot all the points, it will look like this. All right, the next one, what is a y-intercept? it is 3x minus 2. So y-intercept is -2. And slope, it is 3. And we are going to the same strategy. It's going to be 3 over 1. It means you're moving up by 3. And then you're going to move 1 to the right. Let me change the color. Okay, so now let's try to plot y-intercept first. So where's -2? -2 is on the y-axis. And you're moving up by 3. So you have to jump up by 3. And you're going to the right by 1. So the next point will be look like this. And let's go one more point. So you go up by 3. You go 1 to the right. And you go up by 3, 1 to the right. And I already explained this like a long time ago. 3, this is also same as -3 over -1. -3 over -1 still 3, right? So it means that you can move down by 3 and then you can move to the left by 1. So that's why I can go down by 3, and then go to the left by 1. Go down by 3, go left by 1. All right, so if I connect these line, I'm not sure if I connect these line. Okay, 1 second. Yeah, no, I'm not going to do this. So on your paper, I need you to connect all the dots, and you will have like 2 straight line, right? And we need to find a order pair. We need to find an order pair which makes these red and green true. And that point will be this point. Everyone see that? Oh, green and red are together. So this point is 4 and 2, which means when you plug in 4 and 2, this point, it's on the red line and it's on the green line, which means when you plug in this 4, 2 into these two equation, then it's going to be true. So 4, 2 is a solution of this system. If you want to double check, you can plug back in. So this is x, this is y. So I'm going to plug in this to the first equation. So 2 is equal to, oh, 1 second. I put 4, 2, so it had, no, it should be 2, 4. So 4 is y, and if you plug in 2 to here, it should be 2 plus 2. So the first line, the solution makes the first equation true. And let's plug in here. I'm going to plug in 4 to y, and 3 times by 2. I'm plugging into this equation, minus 2. Let's see if it's going to be true. 3 times 2 is just 6. 6 minus 2, which is 4. So 4 is equal to 4. True. So 2 and 4, this is a solution. Okay, I need to fix this. So 2 and 2, 4, this order pair is the solution for this system. We have 3 different kinds of situations when you're talking about a system of equations, when you're talking about the solutions. So the first case is when a system of equation has at least one solution. It is called consistent. You should remember this term, consistent. And a system, inconsistent systems, is if a system has exactly one solution, we call them independent. And if a system has infinitely many solutions, if a consistent system, both are consistent, and we call them dependent system. And when there's no solution, it is called inconsistent system. Please copy it down and remember the terms.